I think it's time for an autopsy, and I'd like to thank Billy for sending me this set of defective flashing shoes, one of which does flash and one of which doesn't. So these things have an LED strip in the sort of the sole area, which has alternating LEDs, and each one can do red, green and blue, so it must be 6 channels. It's got a little button here that you click to actually select the patterns, and it's got a little micro USB port then that you can plug it in to charge. And once you've got it charged and everything's ready to go, you can tuck it into this Velcro flap, and then when you click it, it does various sort of flashing coloured effects. Reusable enough. Except this one does nothing, so I think it's time to open this up. So we'll put the working one out of the way, and we shall see what we can find here. There's not many clues as to how to get in, other than the fact there is a little slit in the back here, so I think that's a good place to start. What's going to be the best way to open this up? Is scissors going to open it up? With feet my size, a British 15, which is an American 16, I don't get nice things like flashing shoes. In fact, it's quite hard getting footwear at all. So what have we got here? I'm seeing the electronic module. Where is the battery? So, I've pulled that back inside, and what we're seeing here is the little classic 8-pin chip, with quite a few wires coming off it. Oh, there's the battery there. It's going down that way. So basically speaking, you're walking on a lithium battery. I'm not sure this is a good idea. Right, okay. So I think we shall use unreasonable force to get into this. I say that, it is a shoe, so unreasonable force might actually have to be very unreasonable force to get into it. Am I going to be able to actually pop that whole module out? It's not proving very easy. Does it pop up? Oop, that's promising. Oh, right, here we go, here we go. That little 2-pin connector is, I'm very suspicious. Oh, and there's a wire off. Oh no, that's just a bit of flat. I'm suspicious that's just unplugged. But this is so trapped in here. Is there a plug in the other bit as well? Yes, there is. So the whole module unplugs. That's quite useful to know. Where is the other end of that little connector? There it is down there. This is not very photogenic, is it? Because everything's in there out of sight. So let's pull the 2 connectors out. Let's plug them back in. And is it, horror of all horrors, just going to be a connector off? Which will be useful to know if you've got a pair of these shoes. What way round does that go? It goes round that way. Is this going to suddenly resolve the issue? No, it's not. Okay, so this is pretty much dead then. Right, let's take a look at this module. I wonder if the voltage on the lithium cell is way down. That's not potted in, is it? Can't be potted in. I think it's just, oh no, that's all resined in. Even the lithium cell is potted into this. Wow. So that's probably to absorb the impact of it being stood on. So it does just look like 2 wires coming out to this little thing out here. Can I split this apart, or is it all moulded in? Let's try splitting it apart. Let's unplug it before I try splitting it apart. So that would mean, effectively, that this must be going via a diode to charge the cell via the protection circuitry. I'm also looking at the wiring here. I'm only seeing 5 wires. That would suggest red, green and blue and maybe the 2 commons. So they're actually alternating between those. That would also go with the animation. So that would be the alternating effect. So they were just maybe put out one colour combination of red, green and blue, and then enable the common for one set of the LEDs, and then change the colour and enable it for the other. And if they had them all on static colours, then all they'd do is they'd put the colour out and they'd alternate between the two channels to make them look as though they're lit constantly. That's quite annoying that this is potted in resin. It also makes me wonder what would happen if that lithium battery went up. Surely that would do quite... I suppose it might vent out the end. That really is quite odd. It kind of makes it hard to go any further into this. That's a bit disappointing. Let's see if I can impale my thumb again with a knife. Or should I use the spudger first? Spudger might be an idea first, though I think this is pretty much impenetrable. No, actually, you know what? This is chewy plastic. I reckon that little circuit board may... Oh, let's just hack it open. Let's just hack it open. They may have actually fed this in like a sort of little shroud. I'm not sure. Either that or it's been sort of plastic injection moulded round it. But there's the little circuit board. And it really is just a circuit board with a button on one side. Let's see if we can peel this off. Yeah, this is taking me a while. Usually does. Ugh. Yeah, the plastic is so thoroughly in there. I wonder if it's actually been moulded into it. So, try and get that. Oh, I've ripped it right off. Okay. Right, let's make a wild guess that the copper coloured wire may be the positive, and the silver wire might be the negative. I should actually check that out by actually plugging the USB lead into that little module there and just check what the polarity is according to what remnants the wire left in that. Actually, I think it's marked on it. Yeah, it's marked plus and minus. So what would happen if I applied 5 volts to that? This is this horrible wire that's got the... It's like headphone wire. It's got the sort of fibre. It's got the fabric as well as the copper, which makes it very hard to do anything with. It's quite hard to solder and terminate. So let's turn this down to 5 volts so we don't have anything really violent going on here. So that's 5 volts it's set at. Let's bring in the croc clips. Stick that onto the negative one, I think. What are we getting here? We're getting no current at all. Now the other one drew 80 milliamps. Oh, maybe if I plugged it in it might do something. Let's plug it in. I could just actually pull this wire out completely, couldn't I? Oh, it's drawing 386 milliamps. Well, that's drawing quite a lot of current. Oh, that's not right. Ooh, that's not right. Let's check the polarity of that then, shall we? So, the coppery one is to the positive. I'm pretty sure the coppery one's the positive. Although it's very hard to tell with what's left of it when it's been soldered. What if I short those together? Is it going to activate the LEDs at all? Nope. So what if I crank the voltage down a bit and stick that clip on again? Oh, nothing now. Oh no, that's unplugged. I'm not doing very well here, am I? This is just one of these days. Let's take a look at what it says in the circuit board at this end. Silver is the ground, and the copper is the 5 volt. Let's hike this out. Yeah, copper is supposed to be the 5 volt. So let's stick this on again and see what happens if it... Hopefully it won't brew up. I'm surprised then that the USB power supply didn't want to put any current into this. So the output is on, it's not drawing any current. I turn the voltage up a little bit and it starts drawing current. So about 4 volts, it's drawing 77 milliamps, which should suggest, the fact is it got a threshold would suggest it is putting a charge into that lithium cell at the moment, hopefully the correct polarity. Let's give it a wee blast and just see if I can get something into this. And it might just have been a bad connection. It might even have been this little module here was faulty in some way. It wasn't making a connection. Not seeing anything really obvious here. Other than that resistor. Is there a resistor in series that was supposed to limit the current in this end? I've just steamed this up with excitement. There is kind of a resistor in the end of this. If you look at the end of that, there is a resistor there. Just between the button and the USB connector. I wonder if that was the current limiting device. It is the current limiting device. That will be why it was drawing so much current. Okay, right. So that is now putting oodles of current in. And I reckon that if I disconnect that now and short those together, maybe... it's working now. So there's been a problem with this module here, seems to be what's actually happened, because this was not putting out the power. Well, you know, there's one way to find out. Let's plug this in. So that would have meant that if this shoe came out with the charge in it, it would have worked initially until that charge ran out. So I'm just going to turn this off, actually. Shunt it to put it off. Let's put it in charge again. So that's charged about 115 milliamps. So let's, I've plugged this into this. Let's get the meter in this and plug it into a USB, generic USB. Let's bring in the usual suspect, the pink USB power supply. And we'll check if we're getting anything out in this connector. So that says plus volt, that says minus volt. It's putting it out. So that's odd. You know what? That connector may actually been out and the battery was completely flat. That's what might have actually happened there. Did I try charging that after I'd put that connector back in? Probably not. So that is a possibility that inside the shoe that connector has been pulled out. So that's worth keeping in mind then, that, you know, this can happen, that, you know, if you've got a set of these shoes and it doesn't work, then you can explore in through this little flap, but it does mean it's quite invasive. It's not really designed for easy access, although theoretically with that wee slot, we'll try another shoe, that's what we'll do. We'll see how it comes out. Where is the other shoe? So you take the insole out, and there's that wee slot there. So theoretically, the module should come out of that if I was to get a screwdriver and just prise it at the back and then pull it down, then all the wiring should come out with it. There it is. So yeah, it looks like you can kind of service it, although you may have to actually open this a wee bit to actually give access to those bits. But still a bit squirmy that these are all potted in resin like that, but I suppose it does protect them to a degree. So yeah, the answer is that if you've got one of these shoes and it's not working, then open it up and check that these little connectors are actually mated correctly. The one is going to the little combined push button and charging port, and the other one is going to the LED strip. So now we've opened this up, now we've got it working, let's take a look, let's get right into it, let's see if we can get the LED strip out. I'm guessing it will just be fed down a slot in here. In fact, you know what? Looking in here, I know this isn't very photogenic again, but looking in here, if I fold that back, the sole has a channel around the edge that it might be possible to pull that strip out. So let's try that. Is it glued in? Well, there's the strip. it is kind of stuck in. Is it going to come out? It's quite tricky. This isn't a great video, is it, from your perspective, because you're not actually seeing really an awful lot, because it really is shrouded in here. Tell you what, you know what, here's a better approach. Let's do the job properly with a pair of scissors. So you can actually see what's going on in here, or not going on as the case may be. That's better. They're well ventilated now. Super ventilated soles. All you need is super glue to mount them on your feet. Right, so here's the module. Here's the inner layer of fabric. The strip is it glued in? Oh, quite tough to get out. It's not pulling out easily. I think that is really sort of stuck in around the perimeter there. But what we can see here of the strip is it's a circuit board, quite a rigid circuit board I have to say. It's not soft at all. Can I get that out a wee tad more? Yes, I can, by using the power of force. So here's the circuit board, which has the little red, green, blue LEDs, quite a small package, with a resistor per LED by the look of it. And when it's plugged into the module, where's the module, a module, and enabled by shorting it out, let's plug it there and there. Quite clever the way they've got a 2-pin connector to enable that. Yeah. There we go. So yeah, it's very simple. It is just 3 connections for red, green and blue, the 2 commons, the little potted module, and a 2-wire charging and activation system, which is quite neat. It must just go through a diode for the charging, and then just detect the slight current shunt when you bridge it with a button. And a little ubiquitous 8-pin chip, as usual. 3 of the pins will be buffered through transistors in here. And then there's the other 2 transistors. Well, let's see, that says red, blue, green there, so that must be these 3 transistors, I'm guessing. And then the other 2 commons are switched to through another 2 transistors. And there's what looks like a little protection chip for the lithium cell. But it's only, I don't see the MOSFET package with it. I can't read a number on it because it's been covered in resin, and that's kind of defeated the number. It's filled in the void of where the number's been etched in. But yeah, interesting enough. So if you have one of these and it's faulty, you can gain access to the module. And one of the things to look for if it's just not charging is to make sure that the little 2-pin connector has come off or broken, but it looks like it could be relatively serviceable. Albeit that it might be a wee bit destructive in the process. So yeah, it was interesting, it was worth looking at. Bonus extra footage. Well, I've sorted that lead back on again, and this is charging properly now. And that does suggest that it was possibly just that lead off, and as soon as the battery had, well, you wouldn't have been able to control it. Maybe it was in use, and during actually walking about on it, that connector popped off or something. That's all I can really think of that could have happened. But while this is charging, it glows red. It just must have I get the feeling maybe it's just a diode, but not just feeding the lithium charging circuitry, but also just maybe through a resistor feeding a small amount of current to these. Initially I thought it was under microprocessor control, but there's no visible pulse width modulation at all unless it's happening very fast. The other option is that it could be, I wonder if it detects the end of charge state. The only way you can find that out is to leave it on charge until the end. It'd be nice if that turned green to show it was fully charged. That would be quite smart. Now, if you were to step in a puddle with these, although this module is fairly well potted, whether that's good or bad, water can still get up the end of the tape, and if it does, it will cause corrosion inside. So I'd say that, these aren't going to last forever, particularly if they get wet. The tape is unusual in that, though it's got this sort of heat shrink around it, It is aluminium core PCB material, which is odd. It's actually quite thick, and it will sort of, I was going to say it will hold its shape, but it's not holding its shape. It's very springy, though it's very clearly got that sort of aluminium-y back to it. I'm not sure the construction of that. It might actually be printed circuit board laminate, or is that just a couple of laminates? Oh, there's only one way to find out, and that's to shave it open just a little bit, trying not to stab. See, I'm going away from the thumb this time. The lesson has been learned. It's not really been learned. I'll never learn my lesson. I always cut towards the thumb. See, I'm doing it again. Oh, bloody hell. It's no wonder I've not stabbed myself again yet. Particularly given this is a nice, new, sharp knife. And they're the best. So, what have we got here? We've got multiple layers. Look at that. It's a metal strip. Is that even steel? It's kind of stainless steel-ish. It's got a slight ferrous content, a slight iron content. Let's shave this up this way again. And I will say, although I'm cutting towards myself again, he said famous last words, I'm kind of cantilevering against that. So unless the knife moves explosively in an uncontrolled manner, like it did last time, that's not going to go anywhere. So what have we got? We've got this steel tape. This is the standard flexible ribbon. I wonder why they've put this next to it. It must just be for rigidness. Rigidity. Rigidness. What is this? Is this adhesive? Yeah, it's adhesive metal tape which has just the thing left on. I wonder if they originally meant to stick that onto the back of it. I'm not sure why it's got the rigidity here. Don't know, because you wouldn't think it sits into that channel of the sole, you wouldn't think it would really go anywhere. But yeah, that was interesting. As I say, if you have a problem with these, then look at these wee connectors first, because it may just be that, well, the culprit in this case, probably this one had popped off while this shoe was being used, and that just let the battery just drain flat and then not take a charge again. But quite a neat little circuit, quite neat indeed. It serves the function.